So we are going to look at inverse trig functions today. So in order to look at inverses, the first thing we should do is we should actually take a look at the trig functions that we know how to calculate from our unit circle values. So for example here, we find the sine of 30, and it's 1/2. Or we find the tangent of pi over 6. Now pi over 6 is the same as 30. Okay, so think about where that position is if you're still struggling with this. And the coordinates there are root 3 over 2, 1/2. So in order to find the tangent, you're going to do 1/2 divided by root 3 over 2. And when you finish that calculation, if you rationalize it, you should get rad 3 over 3. Okay, so you've either have that memorized or you can do that calculation. Today's purpose is a little bit different. We're going to look at this, and instead of saying, okay, I'm telling you the angle location is 30, please tell me the sine of that location, and then you give me this y coordinate. So here you're kind of going, okay, the sine, they're giving me the angle. I'm telling them the y coordinate at that angle. We're going to work with inverse functions. So remember, the inverse notation looks like this. That means they're giving you the y value, and your output is the angle, okay? So for example, if I say, what is the inverse sine of 1/2? The answer is 30 degrees, okay? Because 30 degrees would be a location where the sine is equal to 1/2. So, sorry, this should say equals 1/2. So if we were to rewrite each of these in the form of an inverse, here, it would be inverse sine of x equals y. So remember, inverses use the output of the original function to get you what the input was in the original function. And this would be inverse tangent of -4/3 equals x. So that's how the inverse is related to each of them. Now, they use this notation, but they also use this notation, arc sine. Okay? So arc sine is the same as sine inverse, arc tan, okay, the same as tan inverse. Okay? So that's what we're looking at when we're looking at inverses of equations. So here, we're going to go ahead and calculate inverses. You guys have done this before when you've solved equations. So you've solved equations where you had the cosine of something equals 1/2. And you said, okay, to figure this something out, I'm going to do the inverse cosine of 1/2. We're not going to put it in our calculator now. We have knowledge to figure this out. So you're going to think about where the cosine is equal to 1/2. But here we come across a small problem. So if I try to figure out where the cosine is equal to 1/2, that happens at 60 because 60 has an x coordinate of 1/2. But it also happens at 300 because it also has an x coordinate of 1/2. It also happens at -60 because that would be another name for that point down there. It also happens at, let's say, 420 because 360 plus 60 would end up at that location. So there are infinitely many possibilities that I could list as locations that have a cosine value equal to 1/2. So I want you guys to go ahead and make a side note on your paper about the inverse cosine. So when we go to pick which angle we're going to choose, so they're giving you the inverse cosine of x, and then you're picking this angle. When you answer this angle, we have to set up something as mathematicians so that when we answer this question, we're all picking the same angle. Okay? So they set some limitations. We want to make sure we can answer both questions about both positive and negative x values. So in this quadrant, the cosine is positive. In this one, it's negative. In this one, it's negative. And this one, it's positive. So if I don't want any overlapping answers, I just need to pick one quadrant where it's positive and negative. So mathematicians picked this. Okay? So they say that you're going to pick an answer between 0 and 180 or between 0 and pi when you list your answer. So when you pick this answer to the inverse cosine problem, we're going to pick what they call the principal angle. So we're all talking about the same one. And it's going to be between 0 and 180 or between 0 and pi. Now for sine, things work a little bit differently. The sine is positive in both of these quadrants and negative in both of these. So they pick here. And to make this cohesive, instead of saying from 0 to 90 and from 270 to 360, they go from -90 to +90. Okay? So inverse sine, they're giving you the y coordinate and asking you for an angle. When you're picking this angle as your answer, you're picking a principal angle from negative 90 to 90, or from negative pi over 2 to pi over 2. Okay. And so we're going to go ahead and each time we answer the question, make sure we do that. Now, tangent actually operates in the same quadrants as sine. So when they give you inverse tangent, they're giving you the y over x ratio, and you're picking an angle. Again, you're picking an angle between negative 90 and 90. So now when we go back to this question here, and I didn't know which cosine to pick, I now am going to limit myself to pick the angle between 0 and 180 that has a cosine of 1/2. And that forces me to pick the 60-degree angle, or in radians, what we would call pi over 3. So for part B, they're asking me for the inverse sine of something that you may not think is familiar, but if you go rationalize that, 1 over rad 2 is the same as rad 2 over 2. Okay? So I'm looking for which angle has a sine that is equal to root 2 over 2. That is essentially what this question is asking. Now remember, we just talked about for sine, we're going to pick angles from negative 90 to 90. So I know the angle that has a y coordinate of root 2 over 2 is here at 45 degrees. So my answer to this question is going to be 45 degrees, or pi over 4. So the last question says arctan of 0. Okay? So it's asking me where the tangent is 0. And again, like the sine, we're picking from negative 90 to 90. So here at 0, I would calculate the tangent by doing 0 over 1. So that's where the tangent is equal to 0. So it's at 0 degrees, or 0 radians. So it's the same unit circle information, but you're kind of asking the questions in a different order. And don't forget to pick those correct principal angles. All right, so let's say we wanted to find each value here. Now we have a combination. This round to the nearest hundredth, go ahead and take that off. We're doing this with our unit circle knowledge or other knowledge. Now when I look at these two problems, I'm actually going to start with part B because this number is a number I recognize from the unit circle. Now, the answer to this part of the problem will be an angle, but then my final answer to the problem is to get the cosine of that angle. So first let's think about which angle is it that has a cosine of root 2 over 2. So that would be here at 45 degrees. Okay, so the answer to that part is 45 degrees, or pi over 4. Now I'm going to find the cosine at 45 degrees, which happens to be rad 2 over 2. Now, function and its inverse, we kind of already knew they undid each other, so that process just confirmed for us that that is what happened. Okay. Now, A is similar. The answer to this part is still an angle, and then I'm supposed to find the tangent of that angle. The problem is I don't know any angle that has the sine of 3 over 13. It exists. It's just not one that I've memorized on the unit circle. So how do I deal with this? I can't actually find the angle measure without a calculator, but I can draw a picture of how this angle exists on the coordinate plane. So knowing that it's inverse sine, I know I pick something from negative 90 to 90. Knowing that it's positive, I know I want to pick something from 0 to 90. So I'm just going to draw kind of a generic angle since I don't really know what it is. Here's an angle. Now, if this is supposed to be my angle and it's supposed to have a sine of 3 over 13, remember, we can go back to our triangles. That means if I drew a triangle there and put opposite over hypotenuse, it would form a fraction of 3 over 13. Now, I still can't find the angle, but I can find the tangent of this angle. Look at the picture. Tangent is opposite over adjacent. Opposite is 3. Adjacent is unknown, but with the Pythagorean theorem, I could figure out what that adjacent angle is. So I'm going to go ahead and do that. And I'm going to get that that third side of this triangle is equal to 4 rad 10. So this would be my tangent of that angle, and we would probably see it rationalized. So this would be 3 rad 10 over 40. So again, I don't freak out because I see 3 over 13 and it's not a value I'm used to on the unit circle. Instead, I use an approach where I draw a picture of what's happening. I cannot answer just this question. I cannot figure this out, okay, without a calculator. But I can answer a question that then has me take the sine, the cosine, or the tangent of that angle. Okay? All right, so same ideas here. We'll try these real quick as well, just to make sure you get a couple more examples so you have some good questions for class tomorrow. So remember, the arc cos is the same as the inverse cosine. So this is giving me an angle, and then I want to find the sine of that angle. Okay? So where is the cosine equal to 1/2 between 0 and 180? It happens at 60, because the x-coordinate's 1/2. So the angle is 60 degrees. And now I need to find the sine of 60 degrees. At 60 degrees, the sine of that angle would be the y-coordinate at that position, which is rad 3 over 2. Now, part B here is a little bit different. This is giving me the angle, and I'm supposed to find the cosine. And then once I've found the cosine, which is like the x-coordinate at that spot, I have to take the inverse sine and find an angle of that. So just kind of, my answer here should be an angle. So think about where pi over 3 is. Pi over 3 is the same as 60. At 60, my coordinates are 1/2 rad 3 over 2. Okay, so the cosine of pi over 2 is 1/2. Sorry, the cosine of pi over 3 is 1/2. And then the inverse sine of 1/2. So now I have to think what angle between negative 90 and positive 90 would have a sine value of 1/2. And that would happen here at 30 because it has a y-coordinate of positive 1/2. So my answer here is 30 degrees. Okay? So this is how we work with inverses. We're going to do some stuff to practice it, and you really have to be good at that unit circle knowledge.